So today we shall proceed with few more instructions of 885, and as it is required also for laboratory experiments, we will go through those instructions which are immediately required. So 8085 is an 8-bit processor. So 8-bit arithmetic can be very easily performed. Now we try to develop a program for 6, I think 8-bit addition is over. We discuss in detail, that is there on YouTube. You can verify it anytime. So you write, and again I repeat that you need to write down, and I hope that you are in a degree college, so there is no need like a school that teaches say now write down. It is for you to appropriately find out when to write down and what to write down. So I write a problem statement. So the problem statement is addition of two 16-bit numbers. Obviously, in the problem statement, the source should be given, two sources and destination. So what kind of program? Write a program to add two 16-bit numbers stored at now it is 8000 and 8001, and I hope have you understood this first. You understood this? First 16-bit number is, each memory location is 8-bit. So first 16-bit number is stored at 8000 and 8001 with lower byte at 8000 and higher byte at 8001. Second is stored at 8002 and 8003. Full stop. Store the result at. What should be? Can you complete? Store the result at 8004, 8005. Is it enough? Is it enough? How can it be enough? Addition of two 16-bit numbers is a 17-bit number. हे तर सोपं आहे का नाही, अवघड आहे? हे कळलंच पाहिजे. हे कळलं नसेल तर आज संध्याकाळनंतर, आज संध्याकाळी 5:30 ते उद्या सोमवार सकाळी 10:15 किती तास आहेत? जवळजवळ 64 तास आहेत. त्यातले किमान 30 तास त्याच्यावर घालवायचे. मी सगळे व्हिडिओ देतो त्याचे पुन्हा. is 17-bit number. So memory contains locations of 1 byte each. Therefore, how many bytes will be needed? How many bytes will be needed to act as destination for addition of two 8-bit numbers? How many bytes? How many bytes? 3 bytes, because in memory it is 1 byte as a whole, not 1 bit. So if number is 16-bit, 2 bytes are enough. A number more than 16 bits will require third byte. So 8004, 8005 and is it right? So you can start writing. What instruction we have learnt? Add. Data transfer instructions we know, data processing instructions we know, branch instructions we know. The instructions is add. What is add? Add is one. Add किती byte instruction आहे? 1 byte. Right? Operand किती लागतं addition ला? 2. त्यातला एक काय असतो by default? Accumulator. So it is add R or add M. M म्हणजे memory location whose address given by HL pair. So accumulator is getting assigned to accumulator plus R or M. It is wrong statement because this is 8-bit, this is 8-bit, accumulator is also 8-bit. So accumulator cannot fully contain the answer. So what we need? So carry flag. So 9 bits. A carry flag has 9th bit and followed by 8 bits of accumulator. This is 9. So this is a 9-bit destination for addition of 2 8-bit numbers. Is it right? Lakshya, is it okay? Is it okay? Right. Jump instructions we know, jump on carry, jump on no carry we know. So with this now, jump instruction, add instruction, LDA we know, move M comma A comma M comma A, all instructions we know. So how can we develop the program? I think allowing you to write the program would be nothing but not wastage, I will say. We are not in a so much time luxury so that in the entire classroom time can be given and we can seek the response and then start. So I will write. It is expected that if you are able to write on your own, then it is obvious that you should be able to understand immediately when I write. Is it okay? We proceed. I will write in, there are many ways. I will write in a simple way. There are other ways also. LDA. So numbers are there at 8000, 8001, 8002, 8003. It is a program and result in 8004, 8005, 8006. Is it okay? So I will start. So first number, second number, the result. So for 8-bit also we have assumed that carry will not come and store the last byte at 0. So that I will do here again. So MVIA 00 STA 8006. I assume that carry will not come. Okay. If my assumption is wrong, let us correct it. Then what should be done? Okay, I write directly. LDA 8000. There are some other instructions actually. Right now I am not telling them. Right now I am developing the program using the given instructions, and then I will provide you few instructions which will make the task simpler. Here I have deliberately kept the space. LDA 8000, move A to B, LDA 8002, move add B, STA 8000, here rather than developing further things. I will try to give some scope for you to think and tell how complicated it is. So listen very carefully. This, no issues. Overall carry, I assume that overall carry will not come. So I have stored the third byte of the addition as 0. I need to correct it to 1 in case carry is there, final carry is there. Now I add lower byte of the first number. This we shall deal later. This is what is lower byte of the first number, right? This I take to B. Then I load lower byte of the second number. Karta na ka nahi? Then I add. So I add means now here if I have got XX, YY, PP, QQ. So it is YY number XX, QQ, PP. What I do? XX and PP I add. XX and PP I add. When I add XX and PP, I get a 9-bit number. I get 9-bit number. So how you are supposed to add the next byte? When you, is it clear? So XX and PP you add directly. And you are not supposed to just add YY and QQ, but you are supposed to only add YY and QQ if there is no carry in addition of lower byte. Listen very carefully. When we want to add two 16-bit numbers, 16-bit means 2 bytes. Each number is 2 bytes. Lower byte and higher byte. We add lower bytes of both numbers in the beginning directly. And the lower addition of 2 lower bytes of both numbers will be the lower byte of the final result. Agreed? Is it clear? Actually, I want to be more precise. Addition of lower bytes of 2 numbers will be a 9-bit number containing lower byte and carry. Now, if I am to be more scientific, then what I should how the sentence should be completed? The lower byte of the addition of 2 lower byte. बघा म्हणजे आता विषय असा येतो कळत नाही असं का होतं तुम्हाला तर आपण खूप खोला जातो सगळं कळलं पाहिजे प्रयत्न करतो मग काय जाता काही टप्प्यानंतर तुमचा इंटरेस्ट नसतो तुम्ही डिट्यून होता आणि अदरवाइज व्हॉट जनरल स्टेटमेंट काय ऍडिशन आता बघा अजूनही सांगतो ऍडिशन ऑफ लोअर बाइट्स ऑफ बोथ नंबर्स इज द लोअर बाइट ऑफ द रिझल्ट इज इट क्लिअर मग आता हे स्टेटमेंट हे ढोबळ मानणं बरोबर आहे सायंटिफिकली रॉंग का addition of what I say can anybody point out addition of 2 lower bytes of the number is the lower byte of the result म्हणजे यात काय गृहीत धरलेलं आहे लोअर बाइटची ऍडिशन ही एकच बाइट असते हे गृहीत धरलं जे चुकीचं आहे is it clear addition of lower bytes results in a lower byte and higher byte as either 0 or 1 they carry so to be very scientific lower byte of the addition of lower bytes of 2 numbers is the lower byte of the result म्हणजे म्हणून म्हणून हे सांगताना बऱ्याच जणांना कळत नाही, मग काय बोलतात, आपलं लक्ष नसल्यामुळं अगदी बरोबर सांगितलं सगळ्यांना पटतं. म्हणजे बऱ्याचदा सूर्य पृथ्वीभोवती फिरतो हे सांगितलं तर दिसतच आहे तसं. मग पृथ्वी सूर्याभोवती फिरते हे म्हणजे बऱ्याचदा वर करणी बरोबर वाटणारं चुकीची गोष्ट सांगून थांबलं तर तो शहाणा आहे. इन पूल ऑफ डॉंकीज हॉर्स इज फुल डॉंकी असं होतं बरं. ते होऊ नये याच्याकरता तो काय सांगतो हे सविस्तर एवढा वेळ जातो त्यामध्ये. इज इट क्लिअर? सो लोअर बाइट्स गेट ऍडेड. दॅट आन्सर इज से SS. So this would be SS and there will be a carry 0 or 1, right? That is to be added in YY, QQ and this. So the next addition of lower bytes of both numbers will be performed, and addition of higher bytes is not to be performed only. Addition of 2 higher bytes plus third byte which is either 0 or 1, a carry. So carry is to perform, and then that is second byte of the addition, and in that again carry can come, and that is the 17th bit. लक्षात आलं का? बरोबर. आता हे कसं करणार? How will you proceed? 8,000 and 8,000 were added. So when I am here, what accumulator contains? Accumulator contains SS. Right? Here accumulator contains XX, that goes to B. Accumulator contains Y, PP. So XX in B contains XX, LDA. So A contains PP, add B results, A contains SS, that I stored 8,004. Right? But what I need to check whether carry has come or not. If it has not come, it's different. If it has come, it's different. So this C I am using as a label, which will, because carry flag gets changed after every addition. It is not permanent. So I need to save the status of the carry flag when what this is, it is addition of 3. It is addition of 3 numbers, 2 full 8-bit numbers and 1 bit. Addition of higher byte is not only 2 bytes, 2 bytes plus carry. It's 2 bytes plus third byte is a bit. So what I do, jump on no carry skip, and here I make INRC. So and I come here. So when I have come at the label skip, I have come either directly if carry was not there, or I had come through C, increment C. So can I say that when I come here, now I have to perform addition of 3 numbers, one at 8,001, other at 8,003, and third in C. Is it right? Everybody got it? So now I have already stored lower byte of the result. That purpose is over. Now what I have to do? I have to perform addition of higher byte of first number, higher byte of second number, and register C, and store lower byte of that at 8,005. And if finally carry is there, is it okay? I hope it's quite clear. Right? Now, what is the problem? There is a big problem. Means you should be able to understand it. So what I did, second lower byte of the first number I have taken in accumulator, put it to B. Lower byte of the second number I have taken accumulator. So right now accumulator contains 1 lower byte, B contains other lower byte. I add them. So A now contains what? Addition of 2 lower bytes. In that what is to be done? In that C is to be added. So can I do it like this? Add C here, add C, STA 8,005, jump on no carry ahead. Here I will increment 0 there I had already stored, so now I will store MVIA 01 STA 8006 and I am here at ahead. Is halt. Is it right? Am I right? Yes or no? Or there is some mistake?
After we add B, there will be carry. Again, one more time there will be carry.
Wait, here. That I have taken care here. That carry I have taken care here. Add, I have add, now I have to add 3 numbers. One in B, one in A and one in C. So in A I add B, I add C. So what problem will be there? What problem means now prima facie you feel everything is correct. Can you show me one peculiar example where things will get changed? This is for you, these are very critical situations. Now I will, getting the answer on your own may not be so easy. I will take an example. Take both numbers as 8000. Number is 8000 itself. 8000 plus 8000. What is the result? Unless otherwise it is specified everything is hex. आणि आता हेक्साडेसिमल नंबर सिस्टीम घेतली नाही म्हणजे आज 2024-23 मध्ये नंबर सिस्टीम घेण्यावर वेळ घालवायचा असेल तर मग आपलं पुढे जाता येणार नाही. सी वर्ल्ड इज मेकिंग ए व्हेरी रॅपिड प्रोग्रेस. वी कॅनॉट कंप्लेन. नो अगदी सगळं शिकवलं पाहिजे तर ते तेवढं नंबर सिस्टीम ही कळलीच पाहिजे. कळत नसेल तर आपल्याकडे केली पाहिजे. त्याला पर्याय नाही आहे आज. सो 8000 म्हणजे काय? 1000 प्लस सेम. मग काय आन्सर येईल? झिरो प्लस 00 आलं. 80 प्लस 80 इज 100. 80 प्लस 80 इज 100. Right, it is 100. Means 00 in 8 bytes, 8 byte in 8 bits and 1 carry comes. accumulator मध्ये 80 plus 80 केलं तर काय येतं? आन्सर 00 accumulator मध्ये आणि कॅरी फ्लॅग सेट होतो. आता इथं प्रॉब्लेम काय सांगा कसं होईल? 0000 add B no problem. राईट? कॅरी आलेलं नाही, स्किप झालं. इथं आलो आपण 80 आलं. इथे 80 आलं. 80 प्लस 80 आन्सर काय? आन्सर 00 कॅरी 1 ऍड बी. इथे आपण काय केलं? आय ना सी केलं. सॉरी ऍड सी केलं. ऍड सी केल्या क्षणी काय झालंय? ऍड सी केल्या क्षणी ऍड बी तो जो कॅरी आला होता. ऍड सी नवीन इन्स्ट्रक्शन आहे, त्याला हे कळत नाही ना. मायक्रोप्रोसेसरला तुम्ही कुठली तुमच्या डोक्यात काय आहे हे त्याला कळणार नाही. सो द मोमेंट यू ऍड सी अगेन कॅरी विल बी 0. सो व्हॉट द आन्सर? आन्सर विल बी 0 च आन्सर. बिकॉज फायनली कॅरी इज नाउ दिस जंप ऑन कॅरी विल स्किप दिस पार्ट अँड कम हियर. आता काय केलं पाहिजे? आता काय करायला पाहिजे मग? So You got the question theme. Means after you need to make this as 1 if carry is there, either when we go for addition of higher byte, it is not addition of 2 numbers, it is addition of 3 numbers. And 3 number addition can be done only by adding 2 and adding the remaining in it. But so can you say that I can reverse the sequence? Add C आणि add B केलं तर होईल का? आधी add C केलं आणि इथे add B केलं तर होईल का? add C केलं आणि add B केलं तर चालेल का? का नाही? Right. So there will be another example. There can be another example. F 0 0 simple. F plus 0 0 0 1 हे केलं तर इथं कॅरी आला. इथं कॅरी आला बरोबर. आपण ऍड सी आधी केलं इथं कॅरी आहे 0 झालं. ऍड सी केल्यानंतर काय होणार? हा एक आहे यात सी ऍड केलं आपण तर 0 होणार, कॅरी येणार आणि नंतर बी ऍड करतोय त्यामुळं 0 मध्ये बी 0 आहे तर पुन्हा तो कॅरी गेला. त्यामुळे इन काही जरी काय बघा म्हणजे अगदी प्रत्येक ह्याच्यापेक्षा सोपं जगात कुठे नाही. अजून मी सांगतो लोअर बाईट ऍड केले त्यानंतर हायर बाईटचे वेळ आणि ज्यांना मराठी कळत नाही त्यांनी आता हिंदी पण कसा होईल नेमका इम्पॅक्ट होणार नाही. सो व्हॉट यू कॅन सी यू कॅन चेक यूट्यूब आणि आपण इंग्लिश मध्ये सांगतो साहेब मी यूट्यूब चालते अँड वन ऑफ द फ्रेंड्स कॅन व्हेरी इझिली टेल यू वी ऍड 2 लोअर बाईट्स राईट that is lower byte last 8 bits of that is lower byte of the answer and 1 carry we get. Then we have to add 2 higher bytes plus carry. So for that we need to add 3 numbers. We can add them by adding 1 to other and adding third to the result. So that 2 additions we perform. Irrespective of sequence, even if carry is there in either or both, finally it should be reflected. So what we should do is after every addition, irrespective of sequence you follow, you need to check for carry flag. So what we do, so instead of what I do, I don't store it, I just put MVID 00. I remove it. Okay. Now let try to understand. MVID 00. Now what we do, here we do. Now I write directly because we don't have time that you develop the answer and we proceed. So here we have add B. Then we write jump on no carry. We can write some bypass. Here we make MVID 0. Here is bypass. Adds, right? And then store accumulator at 8005. Jump on no carry ahead. Here also MVID 0 and ahead you do move D comma A SPA 8006. Is it right now? We assume carry will not come. We are taking it in D, and when we come at this point, D to A means if carry has not come anywhere, D would have remained 0 only. So that will come to A, store, halt. And if carry comes either here or here, in either of the additions, we make ds. We make ds. Is it okay? Is it all right? So this is the whole way. Now, the designers have thought this, and what they have done, they have provided one more instruction, that is add with carry. Add with carry का आवश्यक आहे याच्याकरता हे सगळं सांगायला लागतं. So what they have done, so as to reduce the burden on the programmer, they have provided instruction add with carry R. R नको आपण ADCB घेऊया. What is add with carry B? What? Okay, anyway, I think I have created a situation where the justification of these instructions was needed. Now what the instruction will be? ADCB. What it will do? What it? क्या क्या लिखा है? A plus B plus CY, and where the result is stored? Then is it correct or some problem will come? Previously we said that the addition of two 8-bit numbers is a, I told that addition of two 8-bit numbers is a 9-bit, can be a 9-bit number. Now what is happening? How many numbers I am adding? 3 numbers. Then am I sure that the answer would be contained in 9-bit number?
Yes.
Why?
Carry flag carry one.
It is only 1 bit. So listen very carefully. Addition of two 8-bit numbers can be a 9-bit number. However, I don't fully utilize. Listen, आता हे कळत हे बऱ्याचदा असं होतं, हे सांगायचं का सांगायचं नाही, कारण जास्त सांगितलं म्हणून बऱ्याचदा असं असतं की जास्त सांगितलं तर कळत नाही म्हणण्याची प्रॉबिलिटी वाढते. आता listen very carefully, try to understand. No doubt that addition of two 8-bit numbers is a 9-bit number. However, addition of two 8-bit numbers does not consume all combinations of 9-bit numbers. 9-bit number. काय कळलं? Addition of two, listen very carefully. Addition of two 8-bit numbers is a 9-bit number. However, addition of two 8-bit numbers does not consume all combinations of a 9-bit number. 9-bit number ची रेंज किती आहे? आता ह्याच्यामध्ये आणि म्हणून मी आता प्रॅक्टिकल आहे, आता सबट्रॅक्शन मी घेतच नाही वर्गात. का घेत नाही? साइन टेन्शन खूप मोठा गोंधळ होतो, तो नंतर घ्यायचा असतो. पण आता तुम्ही ते पण करा लॅबला. बऱ्याचदा आता 2 गोष्टी असतात. सगळं कळलं म्हणजे इतकं सोपं शिकवलं की सगळंच काय लागलं तर तुम्हाला काय करायची ते शक्यता असते. अरे इंजिनिअरिंग इतकं सोपं आहे, मग आपलं काहीच करायची गरज नाही. लक्षात आलं का? खूप सोपं करून वाटून उपयोग नाही, खूप सोपं करून सांगून उपयोग नाही. म्हणून थोडं अवघड सांगायचं, काहीच कळलं नाही पाहिजे. मग त्यातून तुम्ही काहीतरी प्रयत्न करा. म्हटलं हायब्रिड गोष्ट होतात. सबट्रॅक्शन मी काही सांगणार नाही ते. आणि आता फक्त सबट्रॅक्शन कळत नाही शिकवलं म्हणून तक्रार करू नका. सबट्रॅक्शन ही जाणीवपूर्वक आपण पेंडिंग ठेवलेली आहे. म्हणजे तुम्हाला नंतर जेव्हा सांगून तेव्हा कळेल की ती का पेंडिंग ठेवली. आणि लॅबला काय तुम्ही नेहमी करता तसं करा. काही न करता सगळं तुम्ही एक्सपेरिमेंट तर करताच, जर्नल तर लिहिताच, तो काय अडचण नाही. आता याचं मिनिंग सांगा. Addition of two 8-bit numbers is a 9-bit number, but that doesn't consume all combinations of 9-bit. 9-bit number ची रेंज किती पासून आहे, किती ते किती पर्यंत आहे?
0 to 511.
आता हे डेसिमल घेतो म्हणून 0 to 511 or 000 to 1FF. Agreed? 0 म्हणजे आता 9-bit नंबर आहे, हेक्स लिहितं 4 बिटला एक निबल वापरणार 0 to F. 9 आहे म्हणजे थर्ड जे आहे ते 0 किंवा 1च आहे किंवा मॅक्सिमम 1 आहे त्यातलं. सो 9 बिट नंबर रेंजेस फ्रॉम 000. जेव्हा आपण सांगत नाही तेव्हा सगळं हेच लक्षात ठेवायचं आहे. टू 1FF. 8 बिट नंबर रेंज फ्रॉम 00 to FF. आणि फक्त एकच मला साइंड म्हणजे काय हे कळलं जर नाही ते मला विचारू नका, कारण ते खूप क्लिष्ट विषय आहे. क्लिष्ट आहे म्हणजे काय रॉकेट सायन्स नाही आहे. सुरुवातीच्या काळात तो गोंधळ निर्माण करतो आपण घेत नाही. तर ती जी लॅब असेल ती तुम्ही तुमच्या पद्धतीने करा. तुमच्या पद्धतीने म्हणजे काय तुम्हाला कळलं सगळं. तुमच्या पद्धतीने कळलं म्हणजे काय काही न करता उत्तम पद्धतीनं विषय प्रॅक्टिकल संपवणे ते तुम्ही करा आणि आपण नंतर ते खोडात जाऊया. सो 00 to FF इज द रेंज ऑफ 8 बिट नंबर. तर ऍडिशन मॅक्सिमम कधी येईल? ऍडिशन मॅक्सिमम कधी येईल? दोन्ही FF असतील तर. सो वी गो फॉर FF plus FF. What is the answer? F plus F किती? हेक्स मध्ये पाठ व्हायला पाहिजे. म्हणजे तुम्हाला समजा 6 plus 6 12 लगेच कळतं का नाही? मग 2 पुढं. तसं F plus F 6 plus 6 म्हणजे 1 2. तसं F किंवा 9 plus 9 म्हणजे कसं कळतं लगेच? 9 plus 9 किती? 1 8. तसं F plus F किती? 1. अरे 9 plus 9 1 8. तर F plus F किती? 1E. तेव्हा हे E येणार आणि कॅरी येणार आणि F plus F E आणि हा 1 म्हणजे हा F आणि हा कॅरी. म्हणजे 99 plus 99 केलं तर किती येणार? 1. बरोबर आहे. तुझं किती आलं? 1FE. Addition of two 8-bit numbers when both are maximum is 1FE. आणि एक रेंज कुठे पडत आहे? One more space is pending. So if you add two numbers and a carry, then if FF plus FF plus 1 is 1FF. So हे सगळं कशाला सांगितलं हे सांगा बघू आता. तर हे जे आपण लिहिलंय नुसतं आपण अगदी सुरुवातीला नुसतं आपण असं लिहिलं असतं A is equal to A plus B. This is wrong. Why? Because 8 bit not enough. म्हणून आपण कॅरी टाकला. इनफ झालं तेव्हा. आता तेव्हा इनफ झालं म्हणजे this was enough, right? Now when you म्हणजे वर्गामध्ये आता समजा क्लासची कॅपॅसिटी आहे DA ऍडमिशन होण्यापूर्वी तर क्लासमध्ये जागा आहे. मग DA ऍडमिशन झालं जागा असेल का? क्लास फुल असेल तर नॉर्मल आन्सर नो असा आहे. परंतु प्रॅक्टिकली काय होतं वेन न्यू कम तर आता भरपूर आलेली आहेत. मग मी आले तर चालतंय. वेन न्यू DA स्टुडंट्स कम the original occupants silently leave so that the classroom may be sufficient. हे प्रॅक्टिकल. पण अदरवाईज इथं पुरेसं होतं म्हणून इथं पुरेसं असेलच. This was enough, so we have to ensure whether it is enough after adding carry or not, and we say that now it is enough. Is it right? So there is add with carry, and how I will finish immediately. Now once this is clear, it's very simple. What will we do? MVIA 00 STA 8006. आता D2A करत बसायला पुढे घेतले आपण. LDA 8000 move B2A हे सेमच आहे. LDA 8002 add B STA 8004 LDA 8001 move A to B LD 8003 आणि आता काय करणार मी ऍड बी करणार. काय करणार ADCB add with carry B STA 8005 jump on no carry skip otherwise MVI 801 STA 805 so the 8006 and add skip. Is it okay? The single instruction ADC has made the job quite simple. Is it okay? System variation. In fact, there is one more instruction called as DAD, that is directly system variation, that we shall discuss that next time. And I will put the notice about the tomorrow session on the group. Thank you.